Okay, thank you very much to everyone who's attending the LogPoint webinar today. Just to let you know, we are recording this session and we will be sending out the link later on after the session ends. We will be presenting myself, Andrew Morris, I'm the VP of EMEA, and Jan Cash, Global Solutions Director, the LogPoint UEBA, so User Entity Behavioral Analytics. For those who have some questions, we will be taking the questions at the end of the session. There is a Q&A chat box. If you could just type in your question there, and then we'll be asking those questions after Jan has actually finished his presentation. So over to you, Jan.
Good. Thank you very much, Andrew, and warm welcome to all of you. As Andrew mentioned, we will be looking a little bit deeper into LogPoint UEBA, User Entity and Behavior Analytics. So what are we looking into? UEBA, I'm going to give a little bit of a primer to what it actually is. I'll be presenting some of the UEBA features, how that interlinks with LogPoint. I will also be looking into how you can leverage those use cases. I'll get back to that during this presentation. And also deployment considerations. So what is actually needed and required to run a UEBA solution, LogPoint UEBA solution. We'll be looking into the license model, and then I will give you a live demo of how it actually looks and feels like. So UEBA, what is UEBA actually? If we look at the Gartner definition, it is user and entity and behavioral analytics. So a user is basically a user identity. It could be a AD account. It could be it's typically bound to a person. While when we're talking about entity, it is more of a device. It's a machine. It could be a file share. It could be a URL. So anything that we would say not necessarily human. With user and entity, we then apply behavioral analytics on top. So basically, how does these entities move? How do they access things? How do they traverse the network? And basically, in a definition, this is UEBA. But let's go a little bit back into what does it actually do? How does it work? When we're looking at the algorithms in regards to machine learning, one of the things that is interesting to look at is UEBA or machine learning is actually not as new as we believe it to be. If you dig a little bit deeper into the research, it actually dates back all the way to 1962-ish, where we already have what we call proximity algorithms. So in this context, we are applying it in a security perspective. So using these type of algorithms, we're now applying it onto security analytics, making it faster to detect items. One of the things that I'd like to share or try to envision or help envision is how does it work in terms of data mapping? When we're looking at the way that we work with data, we need to remember that it works in multiple dimensions. So when we are doing something we call data classification, it is actually classified in multiple dimensions. So if you imagine you have a X, Y, and Z axis, you can then start clustering data on the Y axis, the X axis, and the depth axis. Now, when I mentioned the algorithms before, we have something in terms of how do we identify a given data point. So let's just focus on the circles that you see here on the screen and call that class A. When we have a triangle, which is trying to figure out the identity of itself, we use something called K nearest neighbor. So basically that algorithm defines which cluster it belongs to. The importance of this is when we're working with machine learning, it needs to have a cluster. The cluster is basically the way a given data point works. So this could be time. So assuming you have class A and class B, you then have two types. It could be from 12 a.m. to 12 p.m. and then the other way around, 12 p.m. to 12 a.m. You have 2 classes. We'll get a little bit deeper into why that's important and how that actually works in terms of classification and clustering. Now that we've clustered the data, it doesn't really give us much except that we now know that you're part of either circles or you're part of squares. So that's where we put in curve fitting. We're basically putting in boundaries to that data. Once we've put in that boundaries, we can actually use it to look for anomalies. So let's assume that class A, which is from, let's say, 12 a.m. to 12 p.m., starts to actually change its behavior to, let's say, the opposite. So you're working maybe at 4 p.m. on the other side. When that happens, it moves away from its domain. The movement that it does becomes what we use as a risk score or a scoring of the anomaly because it's behaving differently than it usually does over a time period. And basically, that's how we use machine learning and apply that into UEBA from a security analytics perspective. One of the things that is extremely important when we're working with machine learning is data. So when we're doing all this clustering, and you imagine you have multiple dimensions, let's say you have a data variable that is called user. That user needs to be clustered in some sort of fashion. So that person could be part of, let's say, sales division, could be part of financial division, could be part of production, and so forth. But that doesn't really give us much except that we now know this person is a part of several divisions. What is more interesting is what does that person actually do in that given division? So if we start adding in timestamps, so timestamps from your switches, from your routers, from your laptops, endpoints, devices, file shares, you can now start tracking what time that person is doing what on the different items. So if you then enrich that with further with, let's say, file access. So you have a file share server supplying logs to UEBA. Now you also have authentication, or actually it's authorization authentication towards those given file access shares. Is it read? Is it write? With a timing, when is it written? When is it read? And if you now add in perimeter devices, when does this person actually traverse outside the infrastructure? So if you have firewalls, you have web proxies, you now have a much richer mapping of a given user, instead of just only having the department. So again, data is key. The more data points you can add in, and more data points is not more time, it means more types. It is access, it's time, it's user, it's IP addresses like source and destination. You get a much richer behavioral pattern on a given entity or user. So when we're looking at LogPoint UEBA, what is it that we provide? The thing about LogPoint is that we have a common taxonomy, and it's actually one of our differentiators in terms of comparing ourselves with our competitors. We have a much richer and much more mature taxonomy, and that actually means that we don't need to do any mapping when we're adding in the UEBA addition or the plugin as on top of the LogPoint solution. So I'll show this a little bit later in the demo of how that actually looks like. But basically, it works out of the box. Once you've enabled the UEBA on top of LogPoint and you've added in your data sources, the data sources is then automatically already mapped. So when we're talking about a user from LogPoint, the UEBA module already know that this is key value user. Timestamps, that's also already there. Access, it's already there. Authentication, and so forth. So this really makes it much faster in the implementation perspective. When I talked about the UEBA module, the plugin that we have designed to LogPoint actually sends that data to a cloud service. So that cloud service is hosted in Denmark, and we also have it hosted in the US. what actually happens here is that the data we have in the logs, which is already enriched, is then sent to our UEBA platform where all the algorithms, the machine models are being done, and then supplies that risk score back. So if you remember back in what I talked about, if something moves out of its current pattern or normal pattern of behavior, it then creates a risk score. That risk score is what we then use and enrich our existing logs in LogPoint. The advantages of having it in the cloud is, of course, that we keep adding new algorithms and models to our product. And that means you get it immediately. Once it's loaded into that cloud service, then you have availability to that given model any given time. It really, again, empowers your usage of UEBA. And you don't need to have the hassle of maintaining your own hardware, doing updates, doing installations, and keeping those models up to date. This is all done centrally. There's, of course, a question of encryption. Whenever we hear the word cloud, many of our customers, partners, the first thing they ask is, what is actually sent to the cloud? And in this perspective, the keys, the encryption keys, they are stored locally on your LogPoint solution. And the only thing that is sent to the cloud is encrypted key value pairs. Even when it reaches the cloud, the calculation is based on encrypted data. So basically, if there is any data leakage or any data that is being stolen en route to the cloud or in the cloud itself, the data itself is useless as it's all encrypted, and you cannot derive any value out of what is in that package. When we're looking into the examples of what UEBA can do, we do have these use cases. This is not a complete list. This is just an example of what type of use cases that we provide out of the box. Now, I did mention that there are algorithms, there are computational models. If we look at the solution that we provide, we currently have over 400 algorithms. Now, for example, take lateral movement. It's derived out of multiple algorithms that's running. And what it basically does is that you have what we call a data scheme. In that data scheme, we have fields. And fields that we're looking into are, as an example, for example, the user ID. It is the access, authentication. It is the time. It is the destination IP. It's the source IP. And it's for different log sources. And all that together in multiple dimensions, we then can track what we call lateral movement, which is basically when you see a threat trying to get control of multiple devices already inside the infrastructure. Account compromise, account misuse, similar ways of being calculated. Of course, those are different key value pairs and different algorithms. The algorithm itself is, as I mentioned before, the way it actually clusters that information. What is the typical behavior of an administrator, of a financial employee, or, for example, a production employee, and so forth. One of the things that we pride ourselves with is, or so to speak, the value that we believe we give back in terms of adding this feature is the rules. When you're working with SIEM, or maybe even any other type of products, most of the time we need to create rules to actually trigger something. So we need to know, is the employee working from, for example, 8 o'clock in the morning to 4 o'clock in the evening? Then we put that in as a rule. The person works from 8 to 4. If the person is logging on after 4 or 2 a.m. in the evening, it has to trigger an alert. The same thing goes with, let's say, country. If, let's say, a guy called Josh normally logs on from the US, but suddenly logs in from Brazil, we need to create that given rule that we need to track Josh. Is Josh using an IP address that is outside of the US? Now, the thing about UEBA is that it actually maps this for you. and you don't need to think about what are the rules. If, let's say, Josh works in the US regularly from 8 to 4, then that is the behavioral pattern. That's how the data is then manipulated, calculated, and stored, stating that, okay, Josh works from 8 to 4. Anything beyond that is where, if you remember the circle, if it moves out of its given domain, it moves away from its cluster, and the further away it moves, the higher the risk score. That is what creates the anomaly, and that's what gets reported back. Now, it's important to say that when we identify anomalies, it is, as the word says, it's an anomaly. It's not necessarily a threat. We only find things which is out of order, which is something we don't expect or the system expects. And that's where human interaction needs to go in and evaluate. So some of the questions that I get from clients is, how do we tune it? How do we make it, how do we catch false positives? I would like to reverse that comment and say, we're not here to actually tune it to accept false positives, because if we start accepting false positives, it defeats the purpose of finding anomalies. So that's just a comment. Finding the unknown. When we're working with rules, it is difficult to find all types of rules. It's about that needle in the haystack. If we don't know what we're looking for, it's difficult to build those rules for it. And here is where UEBA and the machine learning really shows its force. And that is, once it puts in a pattern, it also looks for patterns that we are not necessarily, as human beings, aware of in terms of how a person or a server or a machine actually acts. So we could actually, let's say we have a server that is doing, let's say, 120 logons per second, but it's something it does normally, but it's not something we've designed it to do. If we have not designed it, we don't necessarily know that it's doing it, and we're not necessarily looking for it. This is where UEBA comes in. Once it defines that pattern, it can show us what is the actual pattern that this entity, device, person is actually doing. The LogPoint solution, if we're looking at the implementation side, due to our taxonomy, it is really about enabling the UEBA. It then ingests the actual logs that's already readily available, loads that into the cloud, and from that generates the risk scores and provides that back. It is a very fast implementation if you compare it to other vendors where you would need to start doing the data mapping so that you actually have the log or the SIEM product itself having to map what is a user ID versus the UEBA module. What is it called there? Is it called a SAM account? Is it called a UID? Is it called name, display name, whichever? So that taxonomy, we've already done that. It's already in the LogPoint solution. Consideration in terms of deployment. So if we have a LogPoint system solution running at the moment, what is the minimum requirements? It is 6.4. And the reason for that is we have features that are necessary to be enabled before you can actually activate UEBA. It is IP to host, and it is LDAP enrichment. The reason for this is when you're building these, when you're using algorithms, it does need a unique identifier. So let's say that we want to know the behavior of a given user. We need to know the user's name or the account name of that person, because that's where we build all the analytics around. So I get questions, yeah, but what if this user has multiple login IDs, which is very typical, use that in different companies? Well, that's a good question. Then you would probably look into the workstation device instead. So if a person, for example, has a laptop and that laptop is personalized, you can, even if you use multiple user IDs, then we can then hone in on the device that the person is actually using. So that's the device entity rather than the user, because then we lock that in and say, this person is now, we map that in, this person used a typical of 5 or 6 different accounts. That is a behavior that the entity knows, because then we're using the entity as the unique identifier. So after 6.4, we of course also have 6.5. That is really where we have the UEBA configuration. So that's where you can enable UEBA. When you have 6.5, you get an extra field in your configuration or an extra button in your configuration that's called the UEBA board. And I'm going to show you how that looks like once we go into the demo environment. When we're looking at the deployment, so how does it actually work? We have different types of architecture. We have an all-in-one box, which basically has the backend collector and the search head in one appliance. We also have where we've separated, where you have the search head for itself that is then connected to the backend. Now, the analytics itself is run in the cloud, but all the encryption and sending of information actually happens from the search head. So when you have an all-in-one, then it's the search head model or the component, the search head component that does the sending. If you have a search head itself, then it's of course the search head that is encrypting the data, sending it to the cloud, getting it back, and then adding that into the enrichment. We've been asked in terms of performance, how much performance does this actually, how much of a performance hit is there when we are implementing UEBA? The rule of thumb is that it's approximately 10% of the search head. But since we have a model where, let's say you have an all-in-one, and it's already running on, let's say 80 or 90% on the performance, what you could do is spin up a new search head and have that search head provide that UEBA functionality. So due to the licensing model that we have, you can spin up as many instances as you want. You could do it on a VMware, you could do it on an appliance, whichever. It doesn't cost extra except for the hardware cost or the VMware spin-up cost. Very important fact is the encryption. I'm going back to this again because it's one of the things that is most asked by our partners and clients. So when we say it's encrypted, what do we actually mean? Well, what we mean is that the key is on the LogPoint search head. It then encrypts the key value pairs. The key value pairs is the encrypted version of that is then sent to the cloud, and all the calculation in the cloud is done on encrypted values. So in the cloud, it does not decrypt any data. All the algorithm is running on encrypted data. Just to reiterate how the data security actually functions in this UEBA setup. The licensing model. So when we're looking at licensing model from LogPoint perspective, the SIEM solution that we have, it's licensed on nodes, while the UEBA is licensed on entities. So what is a node and what is an entity? A node is defined by a device that sends log data, and that could be AD servers, firewall, switches, antivirus management console, that kind of device where it actually puts a log together and sends that out. While when we look at an entity, that is typically a user. It could be a workstation, it could be a server, it could be a file share, it could be a URL, but it doesn't necessarily send, or it doesn't send log data per se. It's more the identification of an entity to which we want to apply the analytics on. So I hope that that was an okay explanation in terms of how this is working. So with that said, I want to go into the live demo. Now I set up a scenario for us. So one of the things that we are going to dig a little bit deeper into is a threat hunting scenario. So basically here we have a guy called Joshua. He works at a global bank, and within his role, he does have access to sensitive information. But in this scenario, unknown to him, his account has been hacked and there is data exfiltration. So I'm gonna walk you through on the demo system to show you what can you actually see from the logs, what are the functions, features that we have that can help and assist in terms of identifying these types of indicators of compromise, and also how do you do reporting and how do you use alerting to help you secure your business. So that said, I am just going to go to the demo system. So here I've already logged on to the system. And just to show you how the UEBA configuration actually works, Just going to go into the settings part and let it load a little bit. So it's in the configuration area, we then go into the configuration and we now have the UEBA board. So this is a 6.5. I'm going to click here. So I want to show you how easy it actually is to configure UEBA. So on this overview, we have already populated it. Here you'll see that we're using Active Directory logs and we're using web proxy logs. Now you can use a lot of different other logs as well, but for the sake of simplicity, we're only doing it on two types of logs. And we'll show you how much you can actually gain just by having two types. Of course, once you're enriching it with more logs, you get a more granular behavior pattern on your entities and your users. On the licensing part, what happens is you can upload a license. So basically, you get a hardware key when you have the 6.5. You send it, from that there is a license file that is generated by us and we'll send it to you. Once you have that file, it's very easy just to browse for it, import it, accept of course, read and accept the end user license agreement, click submit, and you actually have those licenses installed. It's a pretty easy process. Here I have 100 licenses already that's already installed. From those 100, I now select my entities. So the selection of entities happens either through users or from machines. So in the machine part, we have different ways of identifying that. We could do it by an IP, we could do it by a classless IP range, we can do it by host name. The way we typically do this is you upload it through a CSV file. It's a little bit different with users. Here, you can actually do it from LDAP. You can do it from CSV files. I'm just going to do a quick example. I'm not going to add it, but I want to show you the screens. So let's see here, new users. We'll push next. So here we have the ability to add a new enrichment source. The enrichment source is the selection. So I can do it from a ODBC, CSV, LDAP, and IP to host. So I'm just going to go out here because I've already uploaded one, which is the user CSV right here. When I press next, I can now start to select what are the unique identifiers. Now, when we have a batch of users, let's say we have a license for 100 users, but when we're doing an extract of 80, we might have 2,000 users. So to make things a little bit easier for us in terms of not eating away on all our licenses, we can now do a subset. So basically, we can now define specifically in that either your LDAP, ODBC, or CSV, do a subset of who should actually be contained within the license so you don't eat up all the license. It might not necessarily be everybody where you would want to provide or do the security analytics on or the UEBA algorithms on. Once you've decided that, click finish and you've actually got it uploaded. I've already done it. I've called it department 1. So I have 11 users which have already uploaded. And these are the 11 users that will be shown in the logs when I do the searches. The settings part, there is a configuration file that will be sent as well, attached to the license key. Basically what the configuration file contains is to which cloud instance you'll be connecting to, whether it be the Danish cloud infrastructure or the US cloud infrastructure. Here, the repo section is basically, I can just show you how that looks like, is we've built a number of repos that contains the log data. Here, you select which repo contains the log information to which you want to send to the cloud. And it's actually as easy as that. So once you've added the UEBA and you have licensee, you've added in your users, you will get this dashboard. Now, what is it that we see from this dashboard? We can see that it has analyzed quite a lot of events. The anomalies is, as I mentioned, the things that are moving outside of the cluster to which it belongs to, so the standard behavior of a given user or entity. If we go a little bit further, this is the calculated risk score. So what is the distance on that anomaly? So if it's the longer the distance, the higher the risk score. And a distance could, for example, be if I access an AD server or I authenticate myself from Denmark, and all of a sudden I authenticate myself from Brazil or China or Russia, it is very, very far from my normal modus operandi. So the way that I typically do things, and that creates a high risk score. But that is also aggregated to all the other items that I as a person do. So if I, let's say, authenticate myself from Brazil, and then I access card data, but I'm not working in finance, or I'm not working in a role that actually accesses card data, I get an even larger score. So all the items aggregates itself, and from that it starts calculated. So the 22 active risky entities is where we've identified it's gone beyond the threshold of the aggregated risk score. So here, if we look at the users, this is the interesting part, is let's click on that. We can actually see who has actually popped up on this and what is the active risk score that each of these users have. Now, before I dig a little bit deeper into that, when we're looking in the way that we present data, we have the possibility to filter it in many different ways. So just to give you an example of how we can filter data, we can do it based on websites, we can do it on the servers that they log on, the username, the family. The family here is basically our models, our UEBA models. It's a description of what is the anomaly that has been observed. So here, for example, you see user sent an unusual amount of data to a destination. That is what we call the family or a model. So what you see here on these widgets, the data here, they're all interlinked. So what does that mean? It means that if I click on any of these items, let's say I want to see only things that are amber and high risk. So you can see that the anomalies, the top risky users, it changes. So whether I click here in the anomalies, or I click here on the users, or I click anywhere on the histogram, it then updates all the widgets at the same time. So I'm just going to move that down again to the low risk. So when we look at this part, one of the things that is of high value, at least if you ask me, and I've been in the business for quite some time. I've been working with SIEM products and also been sitting in security operations. It's easy for me to zoom in and say, we have a high risk here, this medium risk, and so forth. So already here, I've been served available data where I can quickly go in and investigate, rather than I need to go in and check all the rules, I need to check all the alerts, and then start piecing things together. Here I have a person, an entity. Let's click on Joshua with a very high risk score. We have the entire event chain of Joshua, of what has happened and what has actually triggered those risk scores. So I'm just browsing here. And that history here is really one of the powerful things in terms of the behavior of a given entity. So if I had a standard log solution, I would need to search for every single event of these items before I can actually start piecing together the history of what has this person actually done. Here, I get it all served in one dashboard, and I get it available immediately. So let's have a look at Josh. If we look at the bottom part, the last anomaly that has been triggered here, we can see that he has accessed network shares 38 times in an hour. So before I click on that, I would want to go back in time, because this is not necessarily the start of the events. So I'm just going to go up here and I can select the timeline. Let's just, for the sake of it, look at 7 days. So through that 7 days, I can see Josh Newman, the green bar here, has been moving to a more risky position than the overall risk trend that you see here. And the overall risk trend is basically an average of all the users that it's currently monitoring, or sorry, all the entities that it's currently monitoring, and making an average risk score. So with that said, let's see what is the beginning of Joshua's journey here throughout the system. So if you look at the 14th of July, we can see that Josh has sent approximately 1 gigabyte of data to a website through a first access. That's quite a lot of data, and it's also not necessarily normal. So let's click why did it actually trigger as an anomaly. So when we are comparing Josh to, let's say, standard users, the average maximum is 2.2 megabytes. And the highest for any user that has been seen throughout the registered time, here we're running on approximately 30 days, is 5 megabytes on the first access. So this is highly unusual activity. So let's go a bit further in. So we can also see that Josh has worked in a hour or in a work time that is also unusual. So let's click on that. So we can see here that Joshua has a work hour that is from 3 p.m. to 9 p.m., but all of a sudden here at 5 a.m., there is an activity which is not normal. It really spikes out. So from this, we can tell that something is abnormal. We need to look into it. We can investigate, and we can actually go directly into the raw logs here. This is the same system where you can dig deeper and have a look. So you can go directly into forensics mode from the dashboard. I'm just going to go back here because we're actually more interested in what else has been happening. So if we look at more of this, and I'm going to go into a few more of these that's interesting. We're just going to browse here and see that we have, or at least Joshua has posted 1.3 gigabytes in an hour somewhere. So this is quite a lot of data. Let's have a look at that. Again, comparing itself to what is average for Joshua, what is expected of Joshua, and then comparing Joshua to others in his peer group. It is definitely a lot more than you would expect from his own behavior, but also if you compare to his peer group. So what is a peer group? Peer group is any given entity that works in the same pattern as Joshua. So you will have different peer groupings. Here, of course, it will compare itself to the nearest peer grouping. It's your K nearest neighbor. It is your curve fitting. Who do you belong to? And again, all this is automatic. You don't need to set any rules. You don't need to say Joshua is a member of this group, or Joshua is working from this country, or Joshua works from this and this hour. All of this is calculated automatically. There's no rules whatsoever on any of this. So looking into this 1.3 gigabyte of data that has been sent, let's dig a little bit deeper into the raw logs. What has actually happened? Now we know that something is being sent out, but we don't know where it's going. So if we look at here, we see that there's a destination address. So one of the things, I've cheated a little bit, but basically what we can do when you have threat intelligence, you can then use that as an enrichment. So when I say I've cheated is I've actually built a macro to go out and fetch that information. I'm just going to go and call that threat details. And I'll explain what I've actually done with that. Just see here. There we go, like so. So basically, when I use the macro threat details, I've done a lookup into the threat intelligence source. That threat intelligence source has given me an indication of banned domains or blacklisted domains. So what I've done is I've taken those logs that I've found, I've done a lookup, I've compared it, and I found that that IP address is now in the category that we have identified as a malware command and control server. We've also attached Joshua to it, and we've counted 201 times that this has actually happened. So we know something has definitely happened in terms of or an anomaly, or even data that has been exfiltrated to a command and control server. Now let's go back and have a look at some of the items here. So now we know something has been exfiltrated, but we don't know exactly what has been exfiltrated. So from here, it would be interesting to know what is it that Joshua has actually accessed. And I can see here that he has accessed a network share, and he's done that 38 times. So let's have a look at that and click further into it and see what this is all about. Again, he's accessed something and he's done it more than usual, 38 times. His standard or normal is 1.1, maximum of 2. And he's also, compared to his peer, accessing it a lot more. So again, let's go into the Explorer and see what does the log actually say. So here, reading this is, you need a lot of info or a lot of time to actually sit down and read this if you want to get something out of it. But since I already have an indication and an idea as to what he's looking into, I know I need to look into what is the actual path. So where is it that he's getting his information? And that is the shared local path. So with that knowledge, I can zoom in on exactly that and do a chart count by shared local path. So here I can see what is actually happening. What is it that he's actually accessing? And here we can see he's actually accessing customer data, and he's also accessing a client list. So now we can get an idea as to what has been picked up, but also what has been sent out. So when you attach all those events together, you get a good view as to what is actually going on with user Joshua. So I just want to bring you back to this view here. So we know something has happened, but we need to know what has happened in the beginning. So now we know that there is an exfiltration, but what was the time of compromise? When did something actually happen? So let's go 30 days back and zoom in on this area here, because that's where something triggers in the path. So he goes up on a high risk. Something must have happened in this area. Oh, sorry, let's go back. Just having trouble with my mouse. Just give me 2 seconds here. It's a little bit lively. There we go. Let's see here. Just gonna move that out. There we go. So we've seen that Josh has failed in the login attempt on the card server log bank local. And he has done that for 1 day. So what is anomalous about that? Let's go in and have a look. So let's go in and explore that raw event. Now we know that he has an audit failure. So the authentication has failed here. What does that actually mean? We need to figure that out. So when he has done an authentication failure, we would also want to know from where. Where did he do this from? So let's go here. We'll pipe that. Count by. So we can see he has been using a workstation called Work ST103, and that's where he has failed from. So what can we use that information for? Well, we know this has failed, but let's look at the whole thing in terms of, can we, from the logs, see anything else out of that? So let's remove all the filtering that I've sent here. So, and I'm going to describe what this is, what I'm doing here. I'm going to add something called label equals credentials. I need to put that in. And we would want to go back in time as well. So we have more data to work with. Like so. So we see here that he has actually been using 2 different workstations. The workstation 103 is where he's failed. I just pulled that out from the other logs. But this one, I'm not sure what happened here. There's only a count that he's been using this. So let's have a look here. So what I would like to look for is the event type audit successful. So we could assume that this is his standard workstation. From this, we can derive that probably his credentials has been stolen and someone from workstation 103 has actually attempted to get those files or At least that's where the breach started. Now, when you saw the search query, I added something called label credentials. So when we ingest logs into LogPoint, we have something called labels wiki, which you can see here. We have credentials, extreme, notice, risk, system, UEBA. So this is actually standard out of the box, meaning that you could search on labels itself. So let's say that you want to search something that has something to do with authentication or something that has to do with your credential. You can actually add in those labels and just write label equals credentials. Then it will only search the logs that has something to do with authentication or similar activities. You can also customize your labels if you want to. I'm not going to go into that, but it's just to give you an idea that it is highly customizable, and you can also do a lot of grouping in terms of how you refine your searches. Now, with all this said, we can go in and look at what can you actually do with all of this information. So once we trigger all of this, we have incidents. Now, you don't necessarily need to use LogPoint's own incident management system. You could use others that are out there. The way you can do that, you can integrate it through the email infrastructure or through other means like CSVs or SNPs and so forth. But here, you can also manage all of those types of incidents that pops up. You can click on it, you can view the data, and you can start managing it, put it into resolve, close it, and so forth. So it's just an option. If you don't have an incident management system, you can readily use it actually through LogPoint itself. So one of the things that is quite nice to do is actually when we are looking into alerts. So let me just show you alert rules here. Now, when we are doing the alerting, there are multiple options that can actually trigger. So one of the things that alerts do is that once you have that command or that rule, let me just show you how this looks like here. When that is triggered, it actually feeds into the incident list that I just showed you. Or you can trigger it to send an email, but you can also do something a bit more powerful than that. And that is, let's go in and see the setup notification. So imagine this, that you have a risk score above 90 on a given user, which you saw in the alert. Maybe I went too fast. Let me just go back just to ensure that we have everybody with us here. So you can see here that what this query does is it checks the risk score for 90 on any given user and then publishes a distinct list. So that list contains the users which has a risk score above 90. And this alert triggers every hour. You can set it down to every minute if you want to. When that triggers, then it triggers an action. And that action is what happens here. You can trigger an email notification, you can send an SNMP notification, you can do an SSH notification. Here, what we've done is that we've done an SSH script. So basically, we are logging into, in this regards, we're logging into the Linux instance, and then we're executing a PowerShell, and basically we are disabling the user. The message then contains that distinct list. So whenever a user hits a score above 90, it then triggers this PowerShell, sends it, and disables those users. So you can also do active scripting in terms of when you are receiving alerts based on the UEBA outputs, which I think is quite fancy. So some of the things that we are typically always asked about is when you're doing investigations or you're finding anomalies or threats or indicators of compromise, it's very nice to have dashboards, but you know, management and other stakeholders, they always require something more. So how can we show them that? And that's really where reporting comes in. The way that we build reports is, again, you can customize your report. There's also a lot of rich out-of-the-box reports that's already there. Here, if we look at, for example, the UEBA ongoing investigations, you can provide it through PDF or HTML. I'm just going to get the PDF version. Once I click on that, it actually runs the query that builds the report, and then I can go in and click on that. So, Andrew, I'm a little bit unsure. Can you see the report that I've just opened?
Yeah, I can see it, yeah.
Okay, good. So let me just browse through the report and show you what it actually shows. So basically, many of the queries and all the information that was shown in the widgets and the dashboards, it's actually here in the report. And it comes with descriptions as well. So have we seen something that looks like an exfiltration? What are the details? So what are the IP addresses? What's the destination? What's the method? We can also look at what is the off-hour work. We can look at potential data staging. So if Joshua is moving, for example, data from multiple points into one point, this is typically what we see as data staging, making it ready, packaging it, and making it ready to be shifted off premises. We can also look further and see what has he tried to do. He's also tried to print a document called company roadmap. Here we can also evaluate, is something he should have access to? Is it something he's allowed to print? And so forth and so forth. So we can already here browse on anything and everything that Joshua has done that has triggered an anomaly that we can read about and digest, see, is this a potential threat actually? So this is the ongoing investigation. I'd like to show you the other report as well. We can show you the overview, which is let me just open here, which is basically all the entities that is currently there, and also what is the risk distribution, what are the graphs, what are the bars, and how does it actually look like per user, as you can see here. So I'm just going to browse a little bit further down to give you an indication of what you can see. It gives you basically a count of what are the things or the use cases that are triggered by each individual. How many times has it happened? So we can go a little bit further. What does it mean when we say potential internal recon? So what has been done here, you can see it was very unusual that Nicholas failed access them to a shared drive, having only had one day with failed attempts. So basically, it also gives you the context as to what has happened. And we can see more here. So base user risk score, we can see the threat, we can see the alert that has triggered, and then we can see what is the family. As I mentioned before, the family is the contextual description of our use case that triggered it. And these are the type of reports you can easily generate, but you can also customize it and make it show the bars that you want. You can even tweak the searches so you get different columns. I'm not going to go deep into that today. This was just to give an indication of the reporting and the powerful tool they will have in terms of how you build those reports.
Okay, yeah, and I think we've got 5 minutes left. We've just got a couple of questions here as well. So did you want to?
Right. I'm also, yeah, so that's also about it. So I've reached the end of this presentation. The reporting is the last I would like to talk about. So yes, let's open up for questions.
Okay, so we've got one in the Q&A chat box, and hopefully I can translate this correctly, but it's, please can you just be clear on the encryption in the cloud? Is everything encrypted? Are only the entities identifier? I guess not all are encrypted because you won't be able to analyze them. So I think it's just clarifying what's encrypted and how does LogPoint actually read that data. Is it the raw data or is it something else?
Everything is encrypted. So yeah, I understand the question, and I do get that question a lot in terms of how do you actually run an algorithm without knowing the entity. So if you look at it from an encryption perspective, we don't care whether it's called. Actually, let me just show the slide. So hang on for a moment, because it's easier to describe from the slides. Just give me 2 seconds to get back to that one. There we go. Here. So, whoops, sorry. Here, we don't care whether an entity is called Joshua, called Donald, or Maria, or whatever. I don't know why it keeps going back. There we go. an encrypted data field can be used for calculation purposes. So whether it's called John Doe, as you can see here, or it's called 7FF1358543, the algorithm, the machine learning model doesn't care about that. It can calculate based on that given key value. So everything that is sent to the cloud is encrypted. There is no decryption happening in the cloud at all. Everything is run on encrypted values. The algorithms, the variables, all of it is run on encrypted values. I don't know if that answered the question.
Did that answer the question at all, Frederick? You can also use the chat as well. Okay, I guess it does, unless we hear something more. I think there was another one as well. Just quickly, who specifically would benefit from UEBA and why?
Yeah, so in my line of work, we typically say it's the security analysts. However, looking on the more broader part, I would say it's actually many parts of the organization. So imagine this, that you have your security analyst who's looking into all these data points. The faster an analyst can actually bring some information to the stakeholders. If we just take an example from a client that I've had before, it's when the stakeholder is working, let's say in HR, they don't really have the finesse to dig deep into what a given person or entity is doing. They are only interested in, okay, we've provided them with a contract, we've provided them with maybe user credentials, we provided them, we started the process and delivered the access management to the security team and so forth. That's it. However, if you look at it from a more business perspective, and let's say a security analyst can bring a report to HR and say, okay, so this person has signed a contract. This is the actual behavioral pattern of this person. Does this fit within the role that this person is given? So normally it would be very difficult to write down the entire behavioral pattern of a given person without having machine learning to provide that information. It's really powerful reporting tool giving, let's say in this very specific scenario, to HR. So you've hired this person as a productions manager. Here you go, you see all the traces of what this production manager is doing in terms of work hours, in terms of access, in terms of building access, where does this person go? It really empowers HR to have a much clearer information richness of a given role or person, or what they're doing. So from this perspective, from a reporting and visually giving back to those stakeholders, you can actually provide much more data, which is not necessarily security related, and empower those business functions.
Okay, hopefully that answered that question. Are there any other questions? Okay, well, thank you very much for all of you attending today's session. Thank you very much to Jan as well for doing a great presentation and demonstration. We hope this has been useful. Please don't hesitate to contact us if you have any other questions. So really appreciate it, and we'll make sure this recording is available at a later stage as well. Thank you.
All right, thank you.